Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day everyone. Selamat datang. Welcome to today's See.Think Webcast series number 6. So before we get started, I'd like to go over a few items so that you know on how to participate in today's program. So See.Think Webcast is brought to you by UMP STEM Lab in collaboration with the Ministry of Education, National STEM Centre, Jabatan Pendidikan Negeri Pahang, Pusat STEM Negara dan bahagian kolaborasi industri dan masyarakat ICON. On the left-hand side of the poster is a QR code and a link to the attendance registration for today's program. So every participant will get an e-certificate upon completion of this program. So please register before end of today's session. Before we get started, our webcast today is at live via UMP STEM Lab YouTube channel as well as on bahagian kolaborasi industri dan masyarakat ICON Facebook page. So please be patient if you experience any technical or any internet glitches during the webinar. So if the session is disconnected abruptly at any point of time, please hang on tight as the show will go on and we will definitely be right back in a short while. So you will have the opportunity to submit text questions to today's presenter by typing in your questions into the comment section via YouTube or Facebook. So you may send in your questions at any time during the presentation. We will collect these questions and address them during question and answer session at the end of today's presentation. So if you would like to contact us, please email us at stemlab@ump.edu.my. So before we begin today, I would like to introduce you to UMP STEM Lab. So established back in 2016, UMP STEM Lab is a consolidated effort by the staff and students of University Malaysia Pahang to engage with the community with the primary aim to nurture the interest in STEM education. So via the philosophy of see, think, explore and marvel. So throughout the years, we have collaborated with various industry partners locally and internationally, as well as with agencies from government and non-government organizations. So cumulatively, we have managed to engage with more than 8,000 school children and teachers in our outreach program. So today, we are very delighted to bring to you UMP STEM Lab See.Think Webcast series number 6. So webcasts aim to be a platform for discussion on various trending topics and issues that are related to science, technology, engineering, and mathematics. So it is also our aim to feature role models and icons to share their exciting journey taking up STEM career pathway. And today, we are very delighted to have Pakcik Robot in-house. So before we begin today, I would like to introduce Dr. Zul. So Dr. Zul currently serve University Kuala Lumpur, UniKL, as senior lecturer. And before this, Dr. Zul has quite a various vast experience in doing programs with school children. And before I pass this session to Dr. Zul, I would like to call upon Encik Arman from Jabatan Pelajaran Negeri Pahang to give ataupun untuk memberikan sepatah dua kata. Silakan Encik Arman.
Alright, Assalamualaikum and very good afternoon everyone. Thanks Prof. Mada Dr. Nurul and Noordin, core person for UMP STEM Lab actually. For your information, we JPM Pahang and UMP STEM Lab have been working together for more than 5 years already since 2016. And thank you so much UMP for giving all the facilities and and for the sharings throughout these years. And thank you so much for inviting me to today's webcast number 6, webcast 6 under the See.Think program. So it's very delightful to have our what you call Uncle Robot here, Dr. Zul from UniKL. Thank you so much for willing to share the ideas with all the teachers, most probably. And this is my concern actually. By looking at the topics for today, is how soon is too soon is very important things. I think we can see lots of materials, lots of robotics, lots of coding and everything, softwares regarding the coding and robotics can be found in the markets today, and we should have some knowledge lah in terms of introducing this to our children, whether it's primary or secondary school students. So even to maybe to the preschool students. So I can see now some of the preschool students also are involving themselves in robotics activities. So I think this is a very good topic to see which part, which syllabus or which level should we introduce the students into a certain levels of robotics education. So thank you so much. Congratulations, MP, for rising up these topics, and thank you so much, Dr. Zul, for willing to share all your knowledge and even your experience to us. And welcome everyone to today's See.Think webcast number 6. Thank you so much, Dr. Nurul.
Okay, terima kasih banyak-banyak Encik Arman. Thank you. Okay, betul. Today's topic ni is purposely crafted lah to discuss a topic yang I think that is very close to us. So when we talk about educational robotics, nowadays I think when I went back for Hari Raya, bila balik kampung baru-baru ni, semasa Hari Raya, nenek dekat kampung pun ada tanya, ada buat kelas robotik ke pada hari ni? Dah jadi macam so familiar. Tapi seingat saya dulu lah, the first time I touch a robot, I start to program a robot pada waktu universiti lah, masa melanjutkan pelajaran tu pun sebab ambil bidang kejuruteraan elektrik dan elektronik. Tapi sekarang ni budak-budak pelajar sekolah rendah and also macam saya lah, nenek dekat kampung pun ada tanya berkaitan dengan perkara tu. Jadi bila saya approach, saya tukar ke dalam bahasa Melayu lah untuk lebih spontan. Okay, so bila saya approach Dr. Zul lah untuk nak mempelawa Dr. Zul sebagai speaker untuk siri yang ke-6 2022 See.Think webcast ni. Ini merupakan satu topik yang memang kita craft out, dan saya sendiri pun mengenali Pakcik Robot, Dr. Zul back in 2018 sebelum tu dalam satu program di bawah Petroscience. In fact, kepada all Petroscience facilitator advisor, kalau ada tengok ni, hi kepada semua orang. So memang satu keunikan ataupun satu strength yang Dr. Zul bawa adalah apabila Dr. Zul boleh menerangkan konsep robotik ni ke dalam bahasa yang lebih mudah. Jadi kadang-kala bila kemudahan tu, banyaklah macam platform-platform lain pun ada dalam keadaan yang mudah macam ni, adakah ia bermaksud teknologi robot tu mudah yang boleh dipelajari oleh pelajar sekelip mata seperti tu, ataupun adakah kita terlalu banyak black box kan, ataupun kita macam mengkumpulankan dia dan dia hilang the essence of robotics tu. Jadi sebelum kita mula berbicara ni, saya nak menjemputlah Dr. Zul untuk menyampaikan sedikit presentation, dan selepas tu kita akan adakan forum, dan kita juga buka sesi ni kepada question and answer. Sekiranya penonton ada apa-apa soalan, boleh submit soalan via YouTube comment ataupun via Facebook comment. Silakan Dr. Zul.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Yang saya amat hormati Associate Professor IR Dr. Nurul Hazlina, rakan baik saya, dan terima kasih atas jemputan, dan juga yang saya hormati Encik Arman daripada JPN Negeri Pahang. Okay, terima kasih atas jemputan ni. It's a topic that is close to my heart because I think in terms of my nickname, saya panggil diri saya Pakcik Robotik kan. So there is ada sebabnya untuk perkara tu. There is a reason for that, because kita nak anak-anak kita, atau bila kita pergi approach pelajar-pelajar sekolah rendah dan menengah, mereka lebih selesa atau mereka rasa lebih dekat, dan mereka tidak rasa takut bila dia katakan kita dengan doktor lah, apalah kan, dia rasa amat jauh kat situ kan. So di situ bila kita buat video, pada awal-awal kita buat video untuk memperkenalkan robotics ni, saya mengambil kesempatan secara saya tidak sengaja lah sebenarnya. Tiba-tiba tercakap pula, Pakcik ingin menerangkan tentang, okeylah Pakcik teruslah. So kebanyakan most of my video is I would like to basically gelarkan diri saya Pakcik lah, dan nama Pakcik Robotik tu lekat sampai ke hari ni. Okay, so I would like to just to have the opportunity to share. So I think kita boleh bilingual kan in terms of the presentation for today. So saya share screen Okay. Dah share screen, dah boleh nampak screen ke? Dah boleh nampak screen saya?
Nampak screen appear elok.
Alright, okay. So terima kasih Doktor. Okay, so robotics, how soon is too soon? Okay, so kita tahu, as we know, technology is moving very, very fast. Year on year, children are being exposed to more sophisticated project, more gamification, robotics entering everyday environment, and even coding and microcontroller are now being taught in early education. So, sebelum ni, kita tak nampak lah perkara tu berlaku, kita tak nampak pun dalam DSKP tahun 5, tahun 6, oh ada ayat mikro pengawal. And now we have seen in primary curriculum, we have seen this micro pengawal or microcontroller is being introduced over there. And now we have RBT subject both in secondary dengan juga primary level. Okay, so it's because of the punya teknologi itu sentiasa berkembang, secara di-enhancekan, dan teknologi menjadi semakin mudah. Dr. Nurul ada sebut tadi tentang black box. Di sini kita nak bincangkan pada hari ini bagaimana walaupun kita nampak mudah, dipermudahkan, dikata orang tu supaya semua orang boleh mudah untuk menguasainya, tapi kita takut ianya menjadi satu black box. Maknanya kita guna tapi kita tak tahu pun bagaimana dia berfungsi, kita tak tahu pun bagaimana untuk kita ubah. We don't know how to modify, we don't know to edit, we don't know how to change benda tu. Okay, so that is something that we have to be very, 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 very careful lah. But we should be aware. That is the purpose of today's webcast. We should be aware of the tools that is available outside there. And everybody would agree that STEM education can boost all this critical thinking, increase problem solving skill, enhance our child in terms of their career development. And as we know that the tool that is the go-to tool in terms of the STEM education or exposure, they always link back to robotics. Okay, so a proper strategy must be devised, or we could end up with a negative impact on the desired goal. The desired goal is for us to expose children, anak-anak kita ni, kita nak expose dia kepada STEM. Tapi kalau kita expose dengan silap, kalau kita guna tools yang silap, mungkin mereka akan lebih jauh daripada STEM. Oh, ni susah, ini terlampau complicated, tak boleh, dan sebagainya. Ataupun kalau terlampau mudah pula, dia jadi black box. So there is a very quite kata orang tu fine line yang saya belajar sendiri daripada experience dengan Petroscience, dengan Dr. Nurul sendiri yang banyak melibatkan diri dengan sekolah-sekolah, dengan sekolah rendah, sekolah menengah. Dekat situ baru kita dapat nampak where are the tools, apa dia pro and cons dan sebagainya lah. So today I think that is what we are going to try to share with everybody, cikgu-cikgu, ibu bapa yang ada dalam ni, share with everybody on the experience that we have gone through, experience yang saya alami. Dan saya juga merupakan consultant bagi syarikat yang bernama My Event, yang mana kat sini kita design our own robot. Okay, ini adalah salah satu lagi saya rasa satu kebanggaan lah di Malaysia ni sekarang. In terms of the movement of the robotics companies or movement of the robotic enthusiasts, hobbyists yang mula menghasilkan tools, yang mula menghasilkan robot dan tool software untuk membantu anak-anak kita lah. Kita ada UMP ni, ada alumni-nya yang membuat robot. Ada alumni UMP yang membuat robot, which is konteks saya kilat, robot kilat. Kita ada di sebelah Johor, kita ada grup Sakti, kita ada grup Mecha Robotics, konteks saya Aimi dengan robotnya Rush. So kita ada pakar sumo kita, Encik Zulkanain yang buat Ikido. Kan? So sebenarnya kita dah basically move forward kat situ lah. So hari ni mungkin kalau boleh kita berkongsi lah pengalaman yang ada untuk kita sama-sama melihat bagaimana nak tackle topik for the webcast for today, which is how soon is too soon. Okay, so antara perkara yang pertama is that what is robotics? Allow me just to set the scene. Kita nak settingkan scene ni sebelum kita masuk perbincangan. A little bit of setting the scene. So what is robotics? So there are a lot of definition of robotics. The most common one is programmable machine that can assist human or mimic human action. Nowadays kita nampak kat sini ada contoh ni kan, robot dekat restoran-restoran dah semakin banyak lah. When you go to restaurant, you can see this robot, this waiter robot. Okay, right? They will send the food to the table and things like that, right? So they assist human. Mostly robots in the beginning, it is being built, it is being designed to handle monotonous tasks, task yang rutin, task yang sama je. Okay, so intelligence level of that task is quite low. They just buat benda yang repetitive, yang berulang-ulang. So for example, building car, assembly line and things like that. So that is the first creation of robot and the purpose of robot being built. And now you can see that it has expanded beyond that. It has certain form of intelligence. So when you talk about certain form of intelligence, you pernah dengar mungkin artificial intelligence, you pernah dengar machine learning and things like that. So now we have robot that can fight fires, cleaning homes. I think dah jadi common. You have vacuum robot yang akan vacuumkan rumah dan sebagainya. So and up to the basically higher end, higher spectrum in terms of that, you ada even robot yang boleh buat surgery, robot that is undertaking surgery. Okay, so you can see that there are different level of autonomy, ranging from human control bots. For example, the drone is still can be considered a robot, the drone, but still it is very human control. And up to the basically a fully autonomous bot that can perform any task without any external influences. Okay, so in terms of the types of robot, you have humanoids, you have one that has wheels, you have one that has like a spider, okay? You have drone, you have in terms of nowadays is common in terms of the drone, right? And then you have the ROV, which is boleh masuk dalam air, submersible. So dekat mana-mana sebenarnya, dekat udara ada, di darat ada dan di lautan pun ada. Okay, so these are all types of robot. And a much more specific punya definition some people would like to basically give is that robot is programmable. A robot is a programmable mechanical device that can perform tasks and interact with its environment without the aid of human interaction. So there are specific terms dekat situ or specific wording dekat situ. Satu, benda yang boleh diprogram. So mestilah you nampak ada software and dia perform task, dia boleh perform task and dia boleh interact. So bila dia boleh interact dengan environment sekeliling, maknanya dia ada sensor, dia ada pengesan. Right? So then kita boleh nampak kat situ the element that you must have in a robot. Okay? So that is where you can see, you can debate dengan menggunakan definition tadi tu, definition that it can be programmable, it can do a task without the aid of human interaction. So now a general statement has become much more specific. Okay, so now you can ask student, boleh tanya you punya student atau anak, kita boleh tanya anak kita, kalau dengan definisi macam gitu, adakah vacuum cleaner ni robot? Kalau vacuum cleaner yang ini, kita tak perlu arahkan dia, dalam dia dah ada, memang ada program, dia boleh mengesan dinding, halangan dan mengelak, dan dia boleh ada yang sampai tahap boleh mengesan kotoran, boleh mengesan dust dan sebagainya. So ini akan didefinisikan sebagai robot. Tapi kalau definisi yang kita gunakan tadi lebih spesifik macam yang kita nyatakan, ini vacuum cleaner yang jenis ini tidak boleh dikira sebagai robot. Kerana tiada autonomous, pemerlukan manusia untuk operate dia dan sewaktu dengan dia. Okay. So bila kita tengok elemen-elemen macam gini, saya suka guna slide ni, okay, bila kita menceritakan tentang robot, saya dapati bahawa bila kita kena very well aware dengan audience kita. So kalau kita bercakap dengan sekolah rendah, dengan pelajar-pelajar sekolah rendah, kita kena pastikan nota kita, bahan kita, alatan kita memang sesuai untuk sekolah rendah. Kalau sekolah menengah, sesuai. Tapi kadang-kadang bila kita buat certain assumption, bila kita buat certain assumption, oh budak sekolah menengah mesti boleh buat A, B, C, D, dan kita terus melangkah masuk dalam robotics tu dengan terus melompat kepada elemen yang agak tinggi, nanti dia akan lost. They will be lost. Okay. Kadang-kadang that is why in most of the training, most of the workshop that I've handled ataupun saya terlibat, saya akan make an assumption that the audience is zero knowledge dalam either programming or zero knowledge dalam hardware. That is much more safer. Nota-nota pun yang buat that kind of assumption. Sometimes that is much more safer to approach things that way, because you want to capture the imagination or you want to capture the attention of the students in the first 5 to 10 minutes of any workshop, of any talk, of any lecture. Okay, so if you masuk dengan level yang agak tinggi, nanti kita punya audience tu akan lost. Okay, so that is why I suka buat analogi, gambar dan sebagainya untuk relatekan dia. So when you talk about something that can interact with the environment, that can do a task, okay, and we can see that robot is quite similar or mimics the human behavior. So how can we function? How can a human being function? We have a brain to basically process everything. So definitely a robot should have a brain. In terms of a robot brain is a microcontroller. The robot has a frame, the body, right? And how do we interact with environment? We have our eyes to see, we have our nose to basically smell, we have our tongue to taste and things like that. So similar to robot, must have a camera, for example, equivalent to an eye, right? It has a sensor to detect smells, it has a sensor to detect temperature and things like that. And a human can move. So how can a robot move? Human move using muscle, robot move using actuators or motors, motor, solenoid, pneumatic, all those kind of output actuators devices, right? So another important aspect when you talk about robotics and why robotics is always the go-to tools in terms of teaching STEM is that robotics education actually cut across discipline. It is a combination of a lot of subjects. Dia adalah kombinasi subjek-subjek. Okay, dalam robotics, you akan belajar pasal mathematics, you akan belajar pasal science, you akan belajar pasal physics, you akan belajar pasal engineering. Ada juga dalam robotics, you belajar pasal art. Right? So basically, it's not STEM, it's stream pun you boleh cover in terms of STEAM pun you boleh cover in terms of bila you ajar robotics. And what is much more interesting is that you introduce all this subject that is quite complicated in a very interactive and fun and engaging way. I selalu guna perkataan UR, konsep UR factor. Alright, so kita tunjukkan dia robot, kita ajar dia robot, elemen robot, dia nampak robot bergerak. Lepas tu kita selitkan elemen-elemen fizik yang menyebabkan robot tu bergerak. Kita selitkan pengiraan-pengiraan matematik yang menyebabkan robot tu bergerak. So kat sini dia akan ada, bila dia tengok robot tu bergerak, lepas tu kita kaitkan dia dengan pengetahuan berkaitan fizik, dia akan ada the UR factor. Kan? So dia boleh relate terus dengan apa yang, rather than chalk and talk basis lah. Belajar matematik tanpa mengaitkan dia dengan apa-apa. So robotics allow you to basically gabungkan subjek-subjek yang agak complicated ini, dan dia buat aktiviti yang dia suka, fun, engaging. Dalam masa yang sama, kita akan identify di mana kita nak highlightkan, ni sebenarnya dia bergerak ni berdasarkan pada konsep fizik yang macam ni. Dia bergerak ni, kalau you nak tahu dia bergerak daripada A to B, berapa lama, berapa masa dia, you boleh gunakan mathematics yang sekian-sekian. Alright, so ini lebih engaging, lebih menarik untuk student tu nampak lah. Okay, so in other words, when you expose robotics, is not focusing in one area of skill. Tapi it basically it is encompass and look at the bigger picture. Okay, so that is, I think, the most important aspect when you want to introduce robotics. Okay, and lebih daripada itu, sebenarnya kadang-kadang kita ada there are parents atau anak-anak kita sendiri yang berasa skeptical. Contoh, anak saya tak nak jadi engineer, they are not aspiring to be engineer. Dia bukan nak masuk ni, dia nak pergi accounting, for example. But then the process of participating in a robotic activity, you develop a lot of soft skill. Okay, so it requires, when you let's say you want to you involve in a design or development of a robot, definitely it is a team effort. So it requires teamwork, and then you can communicate with your peers and things like that. So basically it involves all these experiences, all these basically soft skills that can be developed while developing the robot itself. So it builds life and work skill, right? So the teamwork, the learning from mistakes, right? The self-esteem, increase your self-esteem. And that is why I have to point out the role played by Petroscience. It basically create a national level competition, international level competition, where when you do some project activities, robotics activities and things like that, there is a goal of entering a competition, and then can basically compete, and that is where all this soft skill can be enhanced. All right, and then the RBTX, the Petro Science competition, basically is a complete ecosystem. Dia mulakan dengan klinik, dia ajar macam mana nak buat robot. They start with the clinic, and then they start with workshop, and then ada klinik, ada workshop, and then baru dia start dengan competition tu sendiri. So it's a complete ecosystem. It expose the robotics. Okay, so you have your hard skill, your hard technical skill, macam nak buat robot, and also you have your soft skill. Alright, so walaupun mungkin dia tak aspire to be an engineer, but then the soft skill yang dia acquire dia tu, okay, basically is essential to become a successful adult. The communication skill, the teamwork, the creativity, and things like that. Okay, and the most important factor that I've basically, from my experience, that I see that when you involve in robotic education, students become protagonists in the construction of their own knowledge. Bukannya kita chalk and talk, kita bagi dia pun memorize. Now, bila dia terlibat dengan aktiviti yang sebenarnya rupa, dia learn from dia punya mistake, dia belajar sendiri, dia cari maklumat dekat internet and things like that. Dia become the protagonist in the construction of their own knowledge. So ni yang melekat, apa ilmu, skill, apa semua akan melekat dalam kepala dia. Pasal dia sendiri yang create that knowledge themselves. Okay. So in terms of robotics in education, there are two parts. You have the programming part, and then you have the hardware part, the assembly and operation of devices or hardware. So there are two parts. Sometimes when you see in terms of how do you want to approach, sometimes is you look only at the software, and sometimes it's a combination of software and hardware. Kalau you tengok macam sekolah menengah, in terms of sekolah menengah, you still ada subjek ASK, asas sains komputer, kalau tak silap saya, betul? Asas komputer hanya tengok software saja. But RBT basically ada elemen both, ada elemen software dan juga hardware. Okay, so and then this is when you talk about RBT, tingkatan 2, they are exposed to this element mechatronic lah. Sistem elektronik dia belajar, sistem elektrik dia belajar, sistem mechanical, and then dia belajar sistem kawalan. So it's a unique, it's not common dalam kita jumpa kurikulum khusus dalam kata waktu kurikulum perdana lah kan, kurikulum yang memang semua pelajar kita kena ambil, yang ada dalam ni robotics. Negara-negara lain mungkin robotics tu lebih kepada extracurricular. Ada kelab ke, ada summer camp dan sebagainya, ada banking workshop di luar, tapi not as a curriculum in itself. But di Malaysia kita bernasib baik, kita ada kata orang tu elemen-elemen dalam kurikulum tu sendiri. Bermula dengan tahun 5 kalau tak silap saya kan, RBT tahun 5, RBT tahun 6, and then diteruskan dengan tingkatan 2 dan 3 subjek RBT juga. Okay. So dekat sini yang kita kena berhati-hati bila kita nak approach robotic education tu. Okay. What are the tools that we want to use in terms of if we want to approach the robotic education? This is very, very, very critical. Kita tak nak sekolah rendah, kita exposekan dia kepada text-based programming. Bila kita expose kepada text-based programming, dia akan takut tengok benda tu dan terus dia akan lari. Dia kata, oh STEM ni is not my thing. STEM ni is too difficult. Right? So, look at the age level and then sesuaikan dengan apa yang untuk age level tu sendiri. Kalau kita tengok di SKP, lepas ni kita ada sedikit lagi nota tentang how do we want to, in terms of the content of education untuk sekolah rendah dan sebagainya, adakah nota di SKP tu matching dengan that age level? Okay, kita boleh bincangkan. Basically, kita punya approach should basically have material yang sesuai untuk age group itu. Okay, mana yang pernah dengar Scratch, Scratch, MIT punya software Scratch, Lego definitely, and then Arduino, and then you ada M-Block, you ada Microbit, okay. So these are all the tools available and you have to choose the tool yang sesuai untuk age group tu sendiri lah. The wording yang saya amat suka, ya bila kita nak pilih ataupun kita nak guna apa programming language yang sesuai untuk kita approach robotics ni, pastikan program tu is low floor, high ceiling. Okay, so low floor ni maksudnya lantai dia rendah, is a very low floor for anybody to step into the language. Lantai rendah yang sesiapa saja boleh melangkah masuk dalam program tu. Right? Untuk faham tentang program tu, untuk menggunakan program tu dan sesuatu dengannya. Okay. Tapi selalunya benda yang lantai rendah ni, mungkin ada yang pengalaman dengan Lego. Lego guna graphical programming betul. Very low floor, maknanya graphical programming senang je, tarik kan, senang. Tapi benda yang low floor ni kadang-kadang very easy to step into. Dia ada ceiling, dia ada limit apa yang dia boleh buat. Sensor hanya boleh pakai 3 saja. Dia boleh pakai 3 pengesan. Dia hanya boleh pakai 2 motor atau 3 motor saja. You are limited. Dia tak fleksibel. Ni yang isu black box tu tadi. So bila dia mudahkan dekat bahagian situ, dia terlalu rigid untuk kita ubah dia. Dia terlampau black box, kita tak tahu apa yang berlaku dalam, kita tak mampu untuk mengubah apa yang dalam tu, maka dia terhad kepada certain application yang kita nak buat. Tak boleh buat lebih daripada itu. Okay. So that is sometimes things yang you have to look at the language and pastikan dia low floor. Definitely kita nak low floor first and foremost. But the ceiling should be at a certain level. So that you tak hanya boleh buat lampu lap 3-4, lepas tu dah tak boleh buat apa-apa dah. Okay, so you want to have that flexibility to expand. Okay, and you want to have that skill also to expand. Alright, so in terms of what we can see, this is something that I've derived from the internet. Between age group 4 to 6, okay, I was quite surprised. I think Dr. Nurul can share experience juga. I was quite surprised when we involved with petroscience that even as young as 7, 5 or 6, we can they can actually cope. They can actually kata orang tu buat programming robotics yang kita dedahkan. Right, but the tools and the way we deliver the workshop is very important lah. Okay, but in our experience, kita ada paling muda, kalau tak silap saya, umur 5 tahun. Di umur 5 tahun. Tapi aktivitinya lebih pada yang macam contohnya macam ni lah. Aktivitinya macam art and craft, samu-samukan cardboard animals, but there ada battery and things like that. But because of the advancement in technology, because of the advancement in programming languages, okay, mungkin saya boleh share lepas ni Mblock contohnya atau Scratch, yang mana you can see, oh, this is quite simple. Memang budak 6 tahun, 7 tahun pun dah boleh. Janji dia boleh baca, dia boleh membaca, then should not be a problem. Okay, so tapi adalah prerequisite tu, dia dah boleh baca dan sebagainya kan. Okay, but age group 4 to 6, you can watch movies together, you can find robotic club workshop, you can visit a museum, you can join online for discussion, and definitely the battery powered cardboard animal, battery powered, they can assemble and things like that. Okay, and when you go into age 6 years to 8 years, right? So this is where you can start to introduce coding app and simulators. Right, coding app and simulator like this. But definitely it has to be a graphical simulator. Right? Definitely it's going to be a graphical simulator. And then doing simple electronic activities, traffic light, nyalakan lampu, LED, padam nyala dan sebagainya. And again, art and craft. And definitely Lego. Okay. And then we can see the 8 to 12. So 8 to 12, dia dah boleh membaca, terutamanya 10 tahun lah. The magic number here is 10 years. Most research, most literature, banyak berpendapat bahawa 10 years is a good age to start them to get involved in actual robotic. Give them a robotic kit and then basically get them involved in robotics. Okay, so this is where they can start to enter some certain workshop, camp, mula beli buku tentang robotics and things like that, and bagi dia robot and then start to deconstruct the robot and then put them back together and things like that. So after the age of 12, definitely you can expose them to actual tools for robotics and building their own robot and things like that. But I think in terms of the numbers, the magic number is 10 years old, right? So this is the last of the slides. Just would like to show you in terms of the example of graphical program. So when we design certain tools, kita ada design, for example, I hope you can see this, and we design certain kit. Okay, this is an Arduino, right? So this is a kit yang memudahkan. So when we design all of this, termasuk robot ni, when we design all of this, this is where we have to think about student tu punya basically at what age level that this kit can be exposed to. Alright, kita tak boleh shock sendiri masa kita design certain ni. And as Dr. Nurul has mentioned, definitely we want it to be not a black box. Oh, dia boleh buat senang, boleh buat and then boleh nyalakan lampu, boleh gerakkan robot atas bawah, tapi the essence of the technical tu dia tak dapat because dia black box, dia tak boleh nak ubah dan sebagainya. Okay, so this is where kita have to do a lot of brainstorming. So macam ni contohnya, this is a very good graphical programming yang kita rasa I think kita dah tengok kat sini 8 years and above tak ada problem. Definitely at the age of 10 tak ada issue pun untuk digunakan this programming and block ni, and juga definitely a robot kit. So for example, kalau saya nak nyalakan lampu kat sini, it's just a matter of letak header dia, tarik, and then I want it to be looping forever. Okay, nak loop forever. So kat sini I boleh pilih, ni yang issue black box tadi. Contohnya kalau I pilih ni running light interval, besarkan sikit, ni running light interval 1 second direction clockwise. So I nak lajukan sikit, mungkin 0.5, dia akan pusing lampu ni, dia akan pusing secara clockwise. Okay, so kalau saya upload ni, saya boleh terus upload. Okay, so what we do now is the software akan uploadkan arahan tu ke dalam kita punya micro pengawal yang ada atas ni. Okay, so dalam masa try. Okay, so dalam masa tak sampai beberapa ni kita dah boleh ni lah. Fail pula. Sekejap kita disconnect dulu. Connect. Okay. Then kalau kita biarkan coding ni macam gini, ni yang kita masukkan tadi dengan black box lah. Tak boleh pula. Okay. Ni kita masukkan tadi dengan black box. Kalau kita tak boleh ubah program ni, then kita ada issue. Maknanya dia hanya just guna tarik-tarik pakai and then dia tak faham pun macam mana proses ni berlaku. Alright. So kalau kita tengok sini dia akan pusing clockwise lah 0.5 saat setiap LED. Okay. So this is what we call a macam black box juga lah ni. This one line can do all this. Ada berapa banyak perkara hidden kat sini. Contohnya kalau nak nyalakan lampu sebenarnya kena ada LED, kena ada perintang, kena ada wire dan sebagainya kan. So this is where kita kena be careful. Kalau kita nak buat design macam gini pada sekolah rendah, definitely tak boleh lah. Definitely budak sekolah rendah akan terus kata STEM tu is satu benda yang terlalu jauh untuk mereka. Dia tak minat. Tapi kalau budak sekolah rendah kita expose dengan something like this, dia akan happy lah, dia akan seronok lah. Dan kita mula pelan-pelan, okay, kalau nak nyalakan satu persatu, kita ada yang lain kat sini macam gini. Kan, blink 1 second on. Kalau you nak nyalakan dia saja, kita ada macam ni pula. Okay, so kat sini kita boleh exposekan dia pelan-pelan kan, untuk dia jadi minat dan dia tak rasa takut. Dia tak rasa takut dengan STEM tu sendiri atau robotics tu sendiri. So this is contoh lah tools-tools yang kita boleh guna pakai, and definitely dari segi level tinggi dia tu text-based programming macam ni lah. Text-based programming. So text-based programming ni kan, kalau kita introducekan straight away pada yang zero dalam robotics, dalam programming, dia akan terus takut lah. So ni maksud kita tadi dengan proper tool for proper age group, for proper audience. Alright. And then don't take for granted that your audience dah tahu certain skills. Always basically see your audience as someone yang belum zero knowledge in both things. Okay. But they are I would like to just kata orang tu end with this statement lah. Basically, when you talk about learning robotics, it is similar to basically learning language. The earlier you start, the easier it will get. Kalau you nak learn language baru, lagi cepat you belajar, lagi cepat you akan basically jadi pakar dalam perkara itulah. It's just like basically learning a language. And most importantly, when you look at robotics, this is where you learn by doing. You learn by, it is encouraged for you to do mistakes, for you to fail. Alright, so that is where you learn much more. Rather than tak ada apa berlaku, semua berjalan dengan lancar, kan? Nanti the less you learn, basically, if there's no mistakes atau there's no failures. So saya akan berhenti kat situ untuk just setting the scene and things like that. And I guess there's a lot of things to be discussed. Ada banyak perkara yang nak di-discuss atau soalan-soalan, kan? So saya pass balik pada Dr. Nurul.
Okay, terima kasih banyak-banyak Dr. Zul. A very concise and also detailed explanation, especially dalam setting up the environment today lah. Dr. mulakan dengan what are robots. So kalau tengok dekat sini, selain daripada two-wheel robots yang biasa ataupun four-wheel robot ataupun wheel robot ni, banyak lagi komponen lain ataupun komponen robot lah, robotik yang kita ada aware. So boleh kita start
Boleh.
ke? Okay.
Boleh.
Right. Dr. Zul, kalau boleh share sedikit background Dr. Zul.
Ya. Saya punya background.
Your education background. Saya aware Dr. Zul
education
daripada
background.
biomedical engineering kan. So kalau boleh cerita sikit kaitan tu.
Okay, so background saya adalah biomedical engineering, yang mana biomedical engineering ni adalah merupakan kita apply engineering dalam basically developing atau researching atau producing medical equipment atau study dalam bidang medicine dan juga biologi. So nak dikatakan macam contohnya doktor mesin lah. So kalau orang doktor yang tu obat manusia, doktor yang ni obat medical equipment. We are focused on medical equipment. Alright. Dan saya punya study is basically, menariknya study saya adalah dengan kanak-kanak disleksia student. So kita kaji tentang brainwave mereka. Kerana disleksia children ni dia sama macam kanak-kanak biasa. Cuma bila dia tengok perkataan atau dia nak membaca tu, dia nampak macam dia nampak macam huruf tu tunggang terbalik. So tu yang kita study brainwave dia tu kan. Dan yang masalah dekat sini, yang kita sedih kat sini, kadang-kadang bila orang tak tahu, orang anggap macam mereka-mereka ni slow, malas kan. So bila dia dilabel dengan slow, padahal dia nampak huruf tu tunggang terbalik, dia tak boleh baca. Tapi bila orang labelkan dia malas, slow, dia akan memberontak. Dia akan berontak dan dia akan buat perkara-perkara yang tidak diingini lah. So saya buat kajian tentang brain tu, kaji macam mana bezanya dengan kanak-kanak biasa, dengan kanak-kanak ada disleksia, yang kita boleh detect awal. So bila kita detect awal, kita ada all this intervention program that we can basically do lah. So that is biomedical basically, study of using engineering for the advancement and study of medicine and also biology.
Okay, interesting. How long have you been teaching robotics dekat tertiary level, dekat UniKL for example?
UniKL tertiary level. Robotics not per se in terms of subjects or things like that. It's always something yang extracurricular or something that is beyond, that is not part of the syllabus per se. Right, and saya rasa in terms of lecturing or in terms of microcontroller, micro pengawal, whatever, since 99 lecture.
Okay.
1999 and exposed to microcontroller since 94.
Okay.
Dah tua, sebab tu nama pakcik tu. Tua.
Tak apa, young at heart. Okay, tadi masa doktor kupas tentang element of robotics kan, doktor ada sentuh yang ada coding and also ada one more thing is on the electronics. So electronics pun adalah salah satu komponen penting lah apabila kita belajar robotics, betul ya doktor? Ya. Betul.
Okay. Electronics adalah, basically kita ada mikro pengawal. Well, kita ada otak. Tapi otak ni memerlukan kata orang tu sensor-sensor untuk bagi maklumat pada dia. So pengesan ni akan bagi maklumat kepada kita punya controller kan. Dan controller kita dah dapat maklumat tu, dia akan proses. Bila dia proses maklumat tu, dia akan pula kawal output, kawal motor, kawal katakan nak bunyikan buzzer, nak nyalakan lampu. So nyalaan lampu, bunyi buzzer, pengesan yang kita nak ambil maklumat, itu semua adalah electronics. Itu hardware electronics. So itu adalah satu kata orang tu elemen yang agak memang penting jugalah. Tanpa mata, tanpa pengesan, tanpa muscle, tanpa motor kan, dia tidak menjadi apa-apa lah.
Bagaimana Dr. Zul start involved dengan robotics di sekolah?
Start involved dengan robotik di sekolah, start dengan, mula dia dengan Arduino sebenarnya. So sebelum adanya Arduino, coding belum sampai tahap yang kita boleh expose pada pelajar sekolah. Kerana coding tu berada pada tahap yang kata orang tu university level. Dan hardware pun banyak yang university level. Okay, belum ada yang kita contoh macam apa, modul-modul kita panggil. Ni modul, macam ni motor ni modul, yang mana kita tak perlu pun menggunakan breadboard untuk construct data tu. So sebelum adanya Arduino, sebelum adanya kata orang tu modul-modul ni, amat sukar kita untuk introducekan topik robotics ni di sekolah, di sekolah-sekolah, even sekolah menengah sekalipun. Kerana dia memerlukan kata orang tu background knowledge yang agak luas. So bila dia mula introduce Arduino, kerana Arduino ni diintroducekan kepada orang-orang arts. Arduino ni sebenarnya dicipta untuk orang-orang arts, yang belajar arts. Untuk dia buat arca-arca, kemudian letak robot, letak motor ke arca supaya arca boleh gerak. So dia memang dibuat untuk orang yang bukan engineer. It is not designed for engineer, it is designed for non-engineer. So that apa kata orang tu, dia yang boleh guna dan pakai. So you boleh bayangkanlah bila digunakan untuk ajar budak arts, budak ajar student arts, dia basically pemudahkan coding tu. Dia pemudahkan electronics wise, pasal dia bukan engineer electronics. So dia buat modul-modul kat sini yang mana you hanya perlu apa? You hanya perlu sambung wire, sambung dekat Arduino. So, bila adanya dia cipta tu, saya nampak okay, ini dah itu 2008, 2009. Saya terlibat dengan MRSM, kerana kita pun bawah MARA, UniKL bawah MARA, saya terlibat dengan MRSM, pertandingan robotics. Saya nampak okay, now kita ada satu mekanisme yang boleh didedahkan pada student, yang mana kita yakin student tu boleh belajar sendiri. Itu yang penting tu, dia boleh belajar sendiri. Maknanya bukannya kita ajar dia, lepas tu dia hafal, lepas tu dia just luahkan je balik. Tak, kita ajar dia skill fundamental saja, kemudian dia boleh bergerak sendiri. Dia semua berkaitlah, hardware-nya dimudahkan, software-nya juga dimudahkan, kemudian adanya ledakan dari segi maklumat dalam internet tu sendiri. Ada bantuan tutorial dekat YouTube, ada bantuan-bantuan software dekat dalam website-website tertentu. So banyak rujukan. Maknanya self-learning tu mampu dibuat oleh pelajar tu sendiri. Self-learning tu mampu dibuat oleh pelajar sendiri tanpa ada actual kata orang tu micromanage, cikgu sentiasa kena ada kat situ dan sebagainya. Bila nampak peluang tu, saya pun masa tu jadi dijemput dengan MRSM untuk robotic competition dia. Saya nampak okay, ni peluang untuk kita kata orang tu introducekan betul-betul lah. From there kita refine lah kita punya approach. Saya dapat bernasib baik bekerjasama dengan MARA, dengan MRSM, kemudian bekerjasama dengan Petroscience. So dia bagi input dari segi pelajar-pelajar ni punya kata orang tu angle. Pasal kita duduk dekat universiti ni kadang-kadang kita berada pada apa kata tu vantage point yang tak nampak sebenarnya. Kita tak letak diri kita jarang letak diri kita pada mana student tu akan nampak benda ni kan. So bila diberi peluang tu kita take note lah. Kita take note dan kita perbaikilah kita punya content dan sebagainya.
Alright, selalunya kan bila macam kalau kempen mempelajari robotik ni nak dibawa ke peringkat sekolah ni, biasanya antara konten ataupun antara point lah yang akan diletakkan adalah kerana our future will depend a lot on robots. So penting untuk kita nak lahirkan future talent yang robotics ready, for example. So this kind of thing ni macam memberi satu, nak kata problem statement bukan, memberikan satu motivation note lah sebelum satu kelas tu bermula. Tetapi betul ke sebenarnya masa depan kita ni akan memang bergantung banyak kepada robot-robot ni, Dr. Zul?
Kalau kita tengok memang kita kena ada kita kena aware of yang kita panggil knowledge economy dia panggil. K economy kan. At the end of the day, kerja-kerja yang repetitif, kerja-kerja yang monotonous, dia lama-lama kan diambil alih oleh robot lah. So kita tengok dekat restoran pun dah ada yang saya tunjukkan tadi, waiter yang dihantar oleh robot dan sebagainya kan. So dah tak ada lagi kerja-kerja, makin lama makin kurang kerja-kerja collar biru
Collar putih, collar biru kan, collar putih.
collar putih, collar biru yang ni kan. So dia akan katakan dekat Jepun sebenarnya, dia dah boleh, kilang tu dah boleh run hanya dengan 2-3 orang je sebenar-benarnya. Tetapi oleh kerana polisi government dan sebagainya, nanti orang tak ada kerja. Polisi government sebenarnya dia masih lagi ada worker yang on the line lah. Tapi kebanyakan kilang sebenarnya can basically run with only 2-3-4 orang saja. Kerana semua akan jadi autonomous, semua akan jadi gunakan in terms of bukan robot yang bergerak tu, tapi conveyor belt system tu semua is robotics as well. Kan, dia melibatkan elemen mekatronik tu juga. So lama kelamaan nanti yang diperlukan adalah yang menyelenggarakan robot tu, yang diperlukan adalah yang memprogramkan robot tu, yang diperlukan adalah yang akan membaik pulih robot tu. Kan? Itu yang diperlukan. Ada tak orang yang perlukan untuk membuat pemasangan tu, itu robot yang buat. So kat situ kita nampak barulah kata orang tu gaji minimum tu sesuai. Pasal gaji minimum kita 1,500 sekarang kan. Diploma pun kalau keluar pun 1,500 kan. So kita nampak lah elemen-elemen ni berkait. So gaji minimum 1,500, kerja dia adalah kerja at least supervisor. Dah tak adalah kerja operator ni, dah makin kurang. Tapi kalau kita tengok education robotics ni dari aspek hanya technical skill, itu yang kita rugilah. Kerana bila kita belajar robotik, kita belajar soft skill tu sebenarnya banyak. Yang soft skill tu yang kita cuba tekankan lah. Dia bekerja dalam kumpulan, dia communicate, dia belajar from mistake. When you talk about computational thinking is not basically per se berkenaan dengan technical saja. Oh ni komputer. Computational skill adalah life skill. Kita boleh anggap life skill. Bila you tengok problem, macam mana you try to decompose problem tu. Macam mana you nak asingkan problem yang insignificant. Macam mana you nak hanya identify problem yang significant saja pada you punya ni. So proses tu kita kena be very kata tu aware benda tu ada. Pasal kita yang kena tekankan, kita sebagai cikgu, kita yang kena pastikan kat mana dalam kita punya proses PMP tu, pelajaran pengajaran, kat mana kita nak selitkan dan tekankan dekat elemen ni. Kalau tidak nanti dia just go through, dia pun tak perasan sebenarnya apa kan. Dan soft skill ni bukan hanya nak dia jadi engineer je. Soft skill ni berguna dekat apa jua pekerjaan yang dia akan ceburi di kemudian hari. Cara dia approach problem tu, macam selesaikan, cara dia identify, cara dia all this kata orang tu computational thinking punya elemen lah kan. Pattern recognition, pattern abstraction kan. So kat situ dia kena sedar. Tapi definitely you cannot go throughout workshop tanpa you tahu dan tanpa you identify kat mana you nak tekankan all this soft skill nanti saja. So kena adalah that in mind kan. Nanti bila you tak tekankan, student tu pun tak perasan, nanti kita rugilah peluang untuk kita highlight perkara tu.
Okay, so Dr. Zul mentioned just now yang when we talk about educational robotics, bukan hardware, hard skill dia saja, tapi soft skill as well as tadi yang Dr. mention awal tu, dealing with failures. Managing failures ni pun satu benda yang kita kena terap daripada awal ni.
Dealing with failure memang penting. Kita dah nampak, saya Dr. Nurul dengan saya pun dah nampak how anak-anak kita ni deal dengan failures. So competition yang kita was a part of membuka mata kita lah tentang betapa pentingnya kita kata orang tu terapkan ataupun emphasize on how you deal with emotionally, dan juga how you deal dengan failure. Kalau dia tak emotional pun, how you deal dengan failure tu and how you then find the kata orang tu overcome that failure itself. Kita pernah tengok macam-macam lah is either dia can go either very extreme to the left or to the right kan. Kadang-kadang dia terlampau kecewa, dia terus akan ni, ataupun kadang-kadang bila dah failure tu dia belajar dari situ and basically dia akan come back much more stronger lah. So the robotics allows you to do mistakes, to fail, and kata orang tu dengan cepat you boleh then modify, rectify, dan you can gain a lot of advantage from there. Kalau you buat mistake mungkin dekat other areas in life, dia akan tak boleh macam payah sikit nak ni, but in robotics, this is where you can learn to fail. And bila you learn to fail, although it's a negative word, but then sometimes macam saya sebut tadi kan, sometimes kalau you tak fail, you tak banyak belajar. Masa you fail tu yang you banyak belajar. Kadang-kadang fail tu jadi macam seronok pula, macam tak boleh tidur malam kan. Masih lagi fikir, kalau buat macam gini, kalau ubah sikit macam gini, okay boleh ni, boleh. Tu bangun balik. Walaupun dah pukul 1 pagi. And we have seen a lot. Kita tengok, I think majority lah. Student kita kadang-kadang yang sekolah menengah kan, memang dia tak nak kan, makan pun tak nak. Selagi dia tak correct mistake tu, selagi failure, dia upload fail tu, selagi belum dapat penyelesaiannya, selagi itulah dia duduk kat situ kan, kita nampak. Tu yang kita seronok tengok tu kan. Tapi ya, tak boleh lah sampai tak makan kan.
Okay, alright. So last question untuk forum, dan lepas tu kita akan take a break sekejap sebelum saya paparkan soalan-soalan yang dihantar melalui Facebook ataupun YouTube. So soalan yang last ni tadi Doktor ada terangkan tentang text programming as well as block programming. So those two background, macam mana kita nak tentukan when is the best time to transit daripada block programming kepada text programming? Macam mana kita nak tentukan pelajar tu dah ready untuk kita nak expose dia kepada text based programming untuk robotics?
Okay, as soon as dia understand basically the structure of the coding itself lah. Kita tengok dekat dia punya flowchart, ni selalu people take for granted. Orang akan masuk programming tak buat flowchart. Carta aliran tu dia tak buat. So that is something yang kita perlu ubah lah. Bila dah jadi habit, kita dah jadi masalah. So always start dengan ada flowchart. And then dia punya pemahaman tentang flowchart tu adalah penting untuk kita tengok when dia boleh transition daripada graphical kepada text based. Kan? So kalau dia tak buat flowchart, dia just tarik dan kita tak nampak pemahaman dia betul-betul tentang the overall structure of the coding itself. Dia tak faham kat mana dia loop, bila dia loop dan sebagainya. Kan? I always refer back to the ability to explain to us, to explain kepada kita, okay, apa you faham tentang flowchart ni? Kita bagi dia problem. Okay, you buat flowchart, plan you tentang how the program akan dibuat. So kalau dia nampak macam flowchart dia tu pun clear dan dia ni, then kita boleh introduce dia pada text based lah. Kita alihkan dia pada text based. Okay, alright. So kita akan rehat sebentar. Sebelum tu kita ada tayar paparan video dan kita akan kembali selepas ni dengan sesi soal dan jawab lah, insyaAllah.
UniKL, kita datang. UniKL, jadi cemerlang. Universiti Kuala Lumpur mercu tanda pendidikan MARA.
Sertai kami bagi pengambilan ke program persediaan diploma, ijazah dan pascasiswaza hari ini.
Layari unikl.edu.my,
Where knowledge is applied
and dreams realized.
Okay, Dr. Zul. Okay, kita start dengan soalan pertama. Okay, soalan pertama ni saya ambil daripada Puan Anissa Karim. Tanya melalui YouTube. What is the best way to start young robotics?
What is the
Best way to start
young children in robotics? Basically, we have discussed about the age level. So macam tadi, if 4 to 6, definitely just look at movies, play around with this cardboard cutouts, Lego. They are Lego. In terms of the coding, I would refrain if the child can already read and write, then maybe, because even graphical programming, there are still texts that you have to read. So depends on I think we have discussed 6 to 8, just explore them, having fun with them and things like that. You start to expose them to tools 8 to 10, definitely, but definitely graphical based programming. Straightforward. Okay. Even you can use simulation based, even there's no hardware yet, then you can, then when you deal with hardware, definitely cost, there will definitely be cost involved, right? So if you can still use computer simulation and things like that, graphical based, right? But sometimes if at age of 12, 13, this is the first time they see robotics, for example, if that is the first time they see robotics, even at 12 years old or 13 years old or things like that, it is always best to basically expose them to graphical programming first. Right? Yeah, because we don't want to scare them away. That is the best statement that I can say. You would not want to scare them away from STEM. Right? So expose them to something that is quite easy, and then you can gradually basically scale. So maybe the graph of learning is going to be very steep for the 11, 12. You expose them to graphical, then in about 3-4 sessions, you can then expose them to the text-based. Right? So that is something that you definitely I will go. I'll always use the word, do not throw anybody at the deep end of things. Kalau you nak belajar berenang pun, jangan terjun dekat bahagian yang paling dalam. Walaupun you dah umur 20 ke 40, tak kerti berenang, tapi jangan cuba-cuba belajar berenang dekat yang paling dalam, walau macam mana pun. So always belajar berenang dekat yang tempat cetek dulu, pakai pelampung dulu kan. Lepas tu baru pergi kat dalam. Okay, pasal bila dia dah lemas, kalau dia masuk paling dalam, lemas, langsung dia tak nak masuk dalam air tu dah. That is the best analogy lah.
So in general tadi tu, if they are beginners, block programming, graphical programming, and once they can understand flowchart tadi, macam you mentioned about the flowchart and so on, then transit pelan-pelan masuk kepada text programming. Betul ya?
Yes.
Alright. Okay, I go to the second question by Dr. Yasmin. Could robot replace teaching purposes? Could robot replace teachers? Could robot
teaching purposes? Could robot replace teaching purposes? Meaning that you don't teach, it does it mean by you don't teach subject in silo? For example, you teach mathematics and then teach physics, or you just have a subject for robotics where everything is embedded inside. Is that more or less
I think this question can look into two perspectives, Doctor. The first one is that maybe can robot replace teachers in teaching? Robot replacing teacher in teaching?
Robot
I think
replacing
so.
teacher.
Second one, like you mentioned just now, is it an embedded course? Robotics is an embedded course, embedded course, or should it be taught separately, as you mentioned just now? So perhaps you can choose to elaborate from which angle that you would like to address this question.
Robot replaces teachers? I don't think so. Because I think basically it depends. My point of view depends on, okay, if we have a class of 40 students, definitely that one teacher couldn't basically give their utmost attention to every single student. So they will teach in terms of in general. So in that aspect, if you replace that with a video or with a robot and things like that, does it have any kind of difference in terms of the expected outcome? I don't think so. But if you have a small group, for example, 10 students and things like that, then a robot can never replace that human teacher, because that teacher will then know the name of the student themselves. They know how the best way to approach that student, the learning strategy of that student and things like that. So maybe during the teaching process, they will adapt to the student's individual needs, right? Okay, but that cannot be done by a robot. I don't. If there is a artificial intelligence kind of thing that can make a robot sense the learning strategy and adapt their teaching, basically masa tengah mengajar tu dia boleh adapt to the needs of the need, then definitely robot cannot replace the teacher itself. But then kalau you kata macam you ada 40 orang dalam student tu, lecture tu masuk and then ajar kan 100 orang dalam lecture, kalau you replace dengan robot, run video yang sama, ajar, there's no difference lah. By right. Kan?
Okay. So basically tengok teaching ni as a social aspect. At the moment we have long way to go before robotics can be used socially. Setakat ni AI and whatsoever tak boleh beat human lagi lah kan, in terms of social interaction kan.
Yes.
Tapi kalau robotics tu as a tool, that is something yang possible kan. That is what
as a tool definitely. As a tool definitely you must use as a tool. You must take advantage of it. You must take advantage of it and use it as a tool. Kita tak boleh nak kata orang tutup sebelah mata dah, ada robotik. Tak. You must take advantage of it. Tapi kita faham lah, we understand the cost. The cost involved, the training of the teachers itself that is involved. So these are things yang bila kita bercakap dengan cikgu, perkara ni akan timbul lah. Saya pernah terlibat dengan training for RBT teachers seluruh Perak dan seluruh Melaka. Seluruh negeri Perak dan seluruh Melaka di bawah MCMC, SKMM lah, SKMM. So kita dapat tengok RBT punya cikgu, background dia adalah dulu adalah apa kata tu, binaan yang mengajar binaan, yang mengajar kemahiran hidup dan sebagainya kan. So itu adalah satu challenge yang mana definitely to equip the teachers itself with the knowledge or skill of the tools kan. So those are the cost involved, kit tu kena ada dan sebagainya kan. You cannot just show slides and ajar tanpa ada kit depan mata. So those are the challenges that still needs to be discussed further lah.
Okay, I move to this next question. Okay, by Puan Nurul Fazilah. So Puan Nurul Fazilah asked an interesting question here. Tadi kita ada elaborate tentang graphical programming as well as text programming kan. Jadi kalau text pun dah start ajar di sekolah, so what kind of robotics content we use to teach at university level?
Okay, what type of content? Robotic content. So robotic content in terms of university level is going to be much more deeper lah. So kita ada T kan. Kita ada, in terms of knowledge, kita ada T. Kita ada, I would like to call it a T lah. So you boleh anggap bahawa dekat sekolah secondary and dekat sekolah-sekolah definitely kita ajar dia very broad dekat yang the horizontal T, very broad. All the mathematics, physics, it's just sometimes touch base saja. It's just a touch base thing. Touch base on the physics, touch base on the mathematics, touch base on the sense, on the biology and things like that. Touch base. But when you go to university, you dah mula masuk yang vertical, the T that is going vertical. In terms of the physics, much more in depth of the physics itself. In terms of the mathematics, much more in depth of the mathematics itself. So you basically going to have the ability to design your own robot, design your own sensors, design your own actuators and things like that. So in secondary and primary level, you just use the tools. But in university level, you have to then maybe have the knowledge of involved in the designing of things, right? In designing, and definitely in master and PhD level, you need to introduce new knowledge and novel knowledge. So I like to just reference back to the T. In secondary, primary, you know everything, but broadly, and some of it even touch base, very broad. You know everything, yes, but it's very broad. But in university, you will go in depth in certain areas that you are involved in. So if you are in mechanical, you are more, you'll be taught of the design of the casing, and then when you design the casing, it involves the aerodynamics of the things and things like that. During the school, you just use it. Yeah, okay, this one, and you and basically you won't have, you are not required to know why the wheel is like that, while the wheel is at that diameter or this. You just use it. All right. So that I can say is the best description from my point of view in terms of what is the difference between the robotics in secondary, primary, and robotics in the university.
Okay, thank you, Doctor. Okay, the next question by Teacher Lina. So, Doctor, is programming a must in robotics?
Is programming a must in robotics? Yes, I would say so. Okay, let me just think about my answer. Is programming a must in robotics? Yes, if that is depend on the definition that you use. Okay, the definition that I use is that it must be able to interact with its environment without any human interaction. So when it interact with the environment without any human intervention, meaning that it has to sense the environment, and sense is one thing. Reacting to the environment is another thing. So sense is the input, reacting to whatever it senses is the output, right? So you must have a controller or the brain to process this, process whatever it is, process it, and then make certain keputusan, make certain conclusion, and then control the output. For that, you need programming. So my answer will be yes, programming is a must in robotics.
Okay. Just now, Doctor also had related this programming to language, right? Arts, the way we communicate, yeah. So programming language is basically like our own language, but how we communicate with the devices and with the tools yang Doctor mentioned just now.
Yes. Sometimes it's common sense. Sometimes if you look at the language and the command and the instruction, is common sense. It's the same language that we are using. For example, if you want to control, if the temperature goes at a certain level, if the temperature increase above 30 degrees Celsius, for example, you want to then sound the alarm, sound a buzzer. If the temperature increase above 30, then sound the buzzer, right? So the programming language or the instruction will be if else. If the temperature is above more than 30, then turn on buzzer. All right. So at the end of the day, it's very relatable. It's very relatable, and it's very common sense. The problem that we face, the problem that most students face and how I approach in terms of the workshop and the content of the workshop is to highlight to everybody that this is not hard. This is common sense. So do not go into a workshop or do not go into notes thinking that this is technical. I will not be able to survive this. This is too technical. Do not have that kind of mindset. Always have the mindset that everything is common sense. It's not that difficult. Don't overthink. So the word is don't overthink. All right. So that is why most of the notes, most of the workshop that I try to design, always try to make it very apparent, very clear that everything is. If you think as this is very straightforward, it's common sense that it will be like this, right? So that is why the step is very important. Buat carta aliran dulu, buat flowchart dulu. Jangan jump terus ke programming. Kan, nanti bila jump terus programming, you don't have the full picture. Nanti you akan nampak, oh terlampau technical ni. Dia carta aliran tu lah yang akan nampakkan benda tu in terms of layman, in terms of biasa kan. Oh, semua orang boleh faham dan nampak apa yang berlaku. So tu pun sama jugalah.
So kalau macam berkaitan dengan programming ni, antara soalan yang lain yang biasalah yang kita came across kan bila macam ni, dia akan tanya so programming language apa yang patut kita start? Python programming ke Python programming ke, depend on unit where, kalau pakai Python programming or verify ke. So in the end of the day, it's just language kan?
Yeah, it's just language. It's just language. Don't be intimidated by it. And then I selalu kata, tak kenal maka tak cinta. Okay, that so don't have any perception that pre-presumption that it is going to be difficult. That is very very important. And have in mind, dan jangan jump into the deep end pun bila you tengok example. Jangan terus try to buka example yang payah-payah. Jangan try to buka example yang quite complicated. Spend your time properly learning the lingo of the language. Spend the time properly to understand the fundamental of the language. Tak makan masa banyak pun. It's going to be maybe 2-3 hours je untuk you dapat fahamkan lingo language tu. Pasal at the end of the day, programming ni, the best way to learn programming is to copy and paste other people's program. Okay, so the best way to learn, the fastest way, the best way to learn programming is to copy and paste. Look at other people's program, copy and paste. But for you to be able to look at other people's program and understand apa yang berlaku dalam tu, you must have some basic understanding of the lingo of the language. Barulah you buka program orang tu, you tak rasa intimidated. You buka program orang tu, okay, you tahu mana nak copy, you tahu mana nak delete, you tahu mana nak modify, dan you tahu dah expected apa yang akan berlaku dekat output bila you run. Okay, so always find the time to understand or to familiarize yourself with the lingo of the language first. Tak makan banyak masa pun, dalam 2-3 jam. Kalau you berguru dengan orang, lagi cepat. Kan? Lepas tu dia dah mula rasa selesa untuk tengok program orang lain. Tengok, okay, ambil sini sikit, ambil sini sikit. Then you build up you punya skill, you build up you punya knowledge. Never start from zero. People never start from zero in terms of writing a program lah. Mesti dia akan refer to a lot of other program as well.
Okay, sebut pasal berguru ni, dia rhyme pula dengan next question daripada Raja Alam yang tanya dekat sini,
why are robotic classes expensive? Depends. Depends on the provider of the training. So for example, there's a lot of open source languages right now. Arduino is open source, Mblock is open source, Scratch is open source. So kalau dia pilih language yang open source, then there will be no cost on the software side. And then hardware side, there's a lot of option. Definitely kalau you pakai kit yang dah siap, kalau bila you nak buat program untuk sekolah rendah contohnya, definitely elakkan pakai kit yang dia kena pasang macam ni lah. kena pasang sendiri, lepas tu nak kena pasang pakai breadboard apa sebagainya kan. So it's not their level. You tak ada pilihan untuk guna kit untuk memudahkan, nak kena guna kit. So kit akan ada certain price lah. So I would say kalau ada kit je, then you are dealing with dalam 300-400 for the workshop itself, yang mungkin itu kit saja. So the cost of the trainer will depend on the company itself lah, how much yang dia nak charge for the trainer kan. So expensive is very subjective. So maksud expensive dia tu macam saya start dengan Arduino dulu. Dengan Arduino dulu tahun 2009, 2010, satu hari punya kursus RM100 seorang. Satu hari punya kursus RM1 seorang. So depends on people, tengok adakah tu mahal atau tu murah, saya tak pastilah. Very subjective. But in technical world, in a technical engineering punya workshop, RM100 satu hari tu is very cheap lah sebenarnya. Very cheap. Tapi sekarang banyak orang buat training yang over a course of certain period, yang mana dia buat hari Sabtu, setiap Sabtu 2 jam selama 2 bulan, selama 3 bulan. So dia pecahkan macam tu. Dan dia buat kursus macam RM500, RM600 for that 2-3 months kan. So parent boleh hantar kat this training provider setiap Sabtu 2 jam, kadang-kadang ada yang 4 jam setiap Sabtu. Cukup 12 jam dia dah cover all the syllabus lah. Dan dia charge, kalau boleh bawa balik sekali kit tu, kadang-kadang dia charge dalam 500-600 sampai dah pecah over that. So there's a lot of, this is very subjective, there's a lot of approach by ni. Tapi apa yang I boleh comment is in terms of the kata orang tu actual cost of the material itself. Material saja kalau you pakai kit, you dah kit tu saja dah 300 ke atas, 200 ke 300 ke atas kan. Dan kit pun ada macam-macam kit. Ada yang kit yang khusus untuk pertandingan. Bila kit yang khusus untuk pertandingan dan training tu pun khusus untuk pertandingan, dia punya feature dia punya outcome yang dia nak capai tu is very specific. So tak adalah dia nak ajar robotics tu secara wholesome atau secara menyeluruh. Dia cuma fokus pada pertandingan saja. Dan kit dia pun hanya boleh buat benda-benda yang pertandingan tu nak. Very specific. So itu mungkin akan lebih murah sikit. Tapi kalau you masuk kursus yang komprehensi, yang very flexible, yang very wide dia punya tu, dan dia punya robot kit pun boleh ubah bentuk daripada wheel jadi humanoid, jadi apa, dan that is where you can say expensive bila you tengok Vex. Vex you akan tengok, lepas tu you tengok Lego punya ni kan, pasal kit dia tu lain, kit dia tu quite wide, dia punya reaching dia tu kan. Sebab tu saya sebut tadi, saya agak we are quite proud and happy and to see that there's a lot of company Malaysian based create their own robot. Macam saya sebut tadi, Kilat is alumni of UMP sendiri, Kilat. Dan kita ada Aimi from Mechabotics, dia buat Rush. Dan kita ada Sekolah Sakti, kita ada Cik Zulkarnain Sumo. So these people come up dengan kit, dia pun ada bagi training dan sebagainya. So dia basically mewarnakan industri ni lah. Kalau kita hanya bergantung pada Vex dengan Lego, tu memang quite expensive. Tapi kita faham kenapa dia expensive. We need to understand that dia expensive pasal dia can do a lot more kan. Syllabus dia pun cover a whole range ni, tapi tak mampu, ada setengah parent definitely tak mampu lah kalau parent wise dan sebagainya. So
So tadi Dr. ada mention just now yang robotics pun dah jadi macam tuition classes ya, dah breakdown to quite as
Yeah.
plenty ni, tapi dia bagi kecil-kecil lah, ada target-target sikit-sikit.
Betul.
Then the price ni as you mentioned just now subjective, and then dia because of the hardware element tu. Nafi robot pun nak main hardware tak dapat nafikan tu kalau tak dia jadi
Betul.
sini kelas saja.
Betul. Dia tak seronok apa pelajar apa anak-anak kita pun macam tak ada feel lah kan. tak ada keseronokan tu tak ada. So itu antara yang ni lah.
Okay, so we come to a final question insyaAllah hari ni from Miss Emily Chan yang tanya dekat sini, any suitable tools or program for children to learn the robotics?
Any suitable tool or program for children to learn robotics? You can start off with basically any scratch-based programming. M-block is very very helpful. Kalau M-block ni inside M-block there are several tools inside there. It is basically compatible to Arduino, compatible to a lot of kit that is available right now. So I think what I would like to recommend is definitely M-block, because you can do Arduino, macam Arduino ni, you can program this Arduino in M-block itself. So at least you boleh nyalakan lampu, bunyikan buzzer, baca sensor, right? So you can do those kind of things. Don't have the pressure of robotic mesti nak kena ada yang ada tayar yang bergerak and things like that. So start off with how to read from sensors and how to control outputs yang simple like, and you can start that with graphical programming. You can choose M-block, I think is one of the best and one of the cheapest. And pasal Arduino ni you boleh beli yang compatible clone tu dalam RM20, RM20. So you have your hardware already. Okay, so you don't have to wait until you kena beli this thing. Just use a simple microcontroller. RM20 you can get this one. Software is free, and then start your programming. Microbit is also very good starting point. Microbit is only RM90 if I'm not mistaken. RM90, something like that. RM90. So Microbit is Microbit is a microcontroller, micropengawal. So learn microcontroller first. Have fun with it first. Learn how to read input, and then learn how to then control outputs. And then once you maybe be comfortable in that, be much more comfortable in that, then you can go into controlling the wheels and then put everything together. Because robotic is you combine reading inputs and then controlling outputs. You combine everything. But start off simple, like I said, jump at the shallow part of the swimming pool first. Learn inputs, learn output, and then once you feel comfortable, then only you go into the deep end of the swimming pool. Don't jump straight away. Oh, I want to control the motor of the robot. I won't advise to do that. Then you will say that robotics is very hard. I don't want to look at the robot anymore, and then you will go into other areas.
Okay.
So,
Thank you.
To summarize, I would like to recommend Microbit because it has its own software, and then I would recommend you to look at M-block, like the one that I showed, M-block, where you can program the Arduino and things like that. You can put a lot of robot in there that you can program using M-block.
Okay. Thank you very much, Dr. Zul. So tadi in the beginning of the session, we throw out a question lah basically. Adakah robotics today easy and simple enough for a 10-year-old school to learn? So daripada pembahasan kita tadi tu, yes, it is possible. Cuma kita kena tahu macam mana cara untuk carry it out properly without missing those elements, dan jangan tengok benda ni sebagai satu black box now. And also penting untuk kita tahulah bila kita nak transit daripada block graphical base kepada text coding and so on. So saya dengar suara saya echo ni. Anyway, I would like on behalf of I would like to thank Dr. Zulkilfli for your time, and it's a pleasure to have you on board today. Dan insyaAllah ada rezeki kita berjumpa lagi. So salam Syawal, masih lagi Syawal ni.
Masih lagi Syawal.
So insyaAllah kita jumpa lagi. Terima kasih Dr. Zul.
Terima kasih banyak Dr. Nurul dan juga UMP Webcast dan kerana menjemput saya untuk programnya.
Okay, bye-bye.